Hello everyone and welcome. I'd like to start things off by thanking you for joining us today. In this webinar, we're going to be discussing constructible rebar detailing and how we can make that fast and intuitive. Introductions are in order. My name is Ryan Page. I am a Tekla Structures Concrete Application Specialist. Now, I have a degree in architectural drafting and design, and I've spent over 15 years in the civil structural industry, specifically with a focus on rebar detailing as well as constructability review using BIM. Now, I'd also like to take a moment here and to thank my colleague Jared Beeman, who is also a concrete application specialist, for providing some of the content for use in today's webinar. So thank you very much, Jared. The intent of today's webinar is to cover workflows and advantages to detailing reinforcement in a BIM platform, specifically Tekla structures. So with that in mind, we're going to start off with a brief look at a basic overall rebar detailing workflow, and then dive deeper into some specific areas. Then we'll go ahead and touch on some of the main points of creating rebar models, and so that it brings us to a common point of having a preliminary model that we're able to quantify. After that, we'll discuss taking that model and adding those finer details and getting information out where we need it in the form of drawings or maybe even other deliverables for fabrication. But then lastly, we're going to spend some time discussing how those deliverables and the model itself can be used throughout the project lifecycle in a collaborative manner. To begin, we can break down the basic rebar modeling workflow into three main pillars. The first is create and estimate. This is where we're going to establish our concrete structure, whether we create the concrete ourselves or it's supplied to us by someone else on the project. Then at that point, we can proceed to use that concrete geometry and assist in defining our reinforcement using Tekla's native tools or even their components. Now, once that's accomplished, we can get some pretty accurate estimates and start gathering our preliminary quantity takeoff, which is pretty fast and uninvolved. Then we can move on to the next pillar and focus on the finer details where we put together our deliverables. Usually the first step is numbering and performing some sort of constructability review or clash detection. And then from there, we can use that information to go ahead and start creating other outputs such as drawings or bar exports for bending machines in either ASA or Soule formats. So this last pillar is going to bring all of this together and maximize the information out to those invested in the project. We're going to talk about bringing things into Trimble Connect and why we may want to do that, as well as what we can do in Trimble Connect in relation to collaboration during the design phase, as well as the work execution phase. Although this is a basic workflow, there is a lot of potential to unpack here. And with the goal of exploring why we should model reinforcement in a BIM platform, we're going to spend a bit more focus on the second two pillars. But to begin, we'll go ahead and provide a brief high-level overview of the first pillar, creation and estimation, as this is going to inform the rest of our content for the webinar. So the first bullet I brought up in this section of the workflow was creation of concrete. Now, for those of us who focus more on detailing the rebar itself, this is not always an area we wish to spend our time. But if you're new to Tekla structures, you may not realize that concrete is important as it acts as a container of sorts in which we place our reinforcement, using the concrete shape to dictate the initial basic shape of our reinforcement. Now, we can create the concrete ourselves, or we can be shared with us through a couple of different methods, such as Tekla model sharing. But because of this dependent relationship, we can utilize the way our concrete is organized to report on the reinforcement for portions of a project using our POR technology, or even cast units. And this is especially key in speeding up drawing creation. What we want to take away is that accurate concrete is the first step in modeling accurate rebar. It's not difficult to be accurate when modeling your concrete and rebar, but it is something you choose to do. To better illustrate the need for initial concrete in the model and its relationship with reinforcement, we should take a quick look at how you can create reinforcement in Tekla structures. We have a couple of methods. Both are excellent and provide their own advantages and disadvantages compared to the other. First, let's take a look at components. We can choose to populate reinforcement through components that perform multi-step functions and are more often controlled by options and fields in a dialog box. They use native Tekla tools, such as the rebar tools found in the ribbons, and help expedite placement and configuration. Users can specify the parameters in the dialog box and then apply the component to the model. In the case of rebar components, we can use them to apply the reinforcement to the concrete shapes directly. These unique tools allow detailers to create reinforcement methodically and with purpose. Component settings can be saved and then quickly loaded via the drop-down at the top of the component dialog. This allows users to establish and utilize project or company-wide standards for use in not only their current model, but in any model they create going forward. Establishing component and tool settings as you work provides benefits downstream to your overall modeling workflow. The most apparent is going to be saving time and increasing efficiency in detailing from project to project, as well as promoting consistency between detailers when using components to create your reinforcement. But the other key benefit is that users can also go so far as to populate these components in either stages or all at once by utilizing them through something we call the Detailing Manager. Now, the Detailing Manager is an application that utilizes components and applies them en masse. Within the application, detailers establish a tab per condition they would like to reinforce, then select the component and associated save setting to apply to the concrete. The application uses filters to sort out what applicable pieces of concrete will receive this component and which ones will not. The Detail Manager already has a pre-built configuration that can be loaded via its drop-down, and users can utilize this right from the beginning or use it to establish additional or more detailed configurations. The key takeaway here is that once settings are established, detailers can apply components quickly and accurately with minimal setup time and are able to apply them all at once or through a methodical fashion. Rebar components exist to address specific types of concrete shapes, structures, or conditions. Examples of this would be columns, beams, walls, slabs, footings, corner conditions, and so on. They allow users to configure the reinforcement via dialog boxes and then apply them directly to concrete shapes. Rebar components adapt to changes and updates in concrete geometry instantly, reducing tedious rework. The components account for many parameters applicable to certain situations, most commonly being bar size, grade and spacing, edge and clear distances, splice and stock lengths, end conditions, and even unique naming of reinforcing bars. They provide consistent and repeatable results through the use of saved settings. Rebar components are ideal for the beginning stages of rebar modeling, whether that's pre-construction or just initial bar placement, or even just estimating how much bar may be required on a project. It's important to keep in mind that rebar components can be, in certain applications, a little limited, and they may require additional edits outside of the dialog box, which is easy to achieve after placing the component initially. The other method for populating reinforcement would be to utilize the native tools found in the ribbon menus. These tools give users the fidelity to model an entire structure by first conforming the bar's general shape to the concrete geometry, similar to components. Now, once the shape has been applied to the concrete, the detailer can then begin to add the particulars such as end conditions, splicing, cranking, or couplers, adjust spacing, provide different spacing zones. Specific tools exist to apply crossing and longitudinal bars or circular reinforcement, or even applying reinforcement by concrete face or even bend shape specifically. Users can work methodically throughout the entire model and detail the reinforcement as they go, providing a high level of accuracy, flexibility, and detail. This approach also lends itself to reviewing the reinforcement as it's being modeled, so it's easy to spot errors or design oversight in interaction in 3D space. With the native tools found in the ribbon, the mentality is to start broad and then refine as an approach. These tools allow for accurate rebar modeling, but with that, they do require a little more input and a little more time to apply than, say, with components. However, the result is far more specific and customizable. In reality, many detailers use a combination of both methods, where components are great for quick creation and estimation, and the tools allow for finer details in taking components across the finish line. Again, with the native tools, the approach is to start broad and then refine. Properties for the bar such as material, size, spacing can all be specified when placing the bar via the Properties pane on the right-hand side of Tekla structures. Modifiers can then be added to include hooks, splices, cranking, offsets, and much more. The native tools are ideal for general rebar detailing as well as complex, unique, and congested areas of reinforcement. The input for this type of tool is a bit more directly related to the concrete and less to do with dialog options as with the components. They are incredibly flexible tools in regards to configuration, customization of reinforcement, and unique conditions. In reality, many detailers use a combination of both methods, where components are great for quick creation and estimation, and the native's tools allow for those finer details, taking the components across the finish line for fabrication level detail. The point here is that Tekla Structures provides options and methods to ensure efficient and accurate rebar detailing in a fully 3D constructible environment. Now, regardless of which combination of methods we choose to populate our reinforcement, the end goal here, initially, is to understand what we have inside our model. That's going to be our first benefit, and then how it relates to itself and other objects such as concrete and hardware and so on. Now, with BIM in general, and Tekla specifically, as we create our objects, such as the rebar or concrete and hardware, the software is actually doing a bit of the heavy lifting for us. First, it's going to know the physical properties of anything that we model. So that means weight, size, lengths, and so on. Secondly, the software can easily tabulate how many of each item there are and whether they're identical or different. Now, because of this, it becomes very easy and fast to report on what's inside of our model. Now, one way to utilize this information that's housed inside our objects is the Reports tool, which is found on the Drawings and Reports ribbon. Now, reports stem from predetermined templates that will read the entire model or a specific portion of our model that we specify and report back on a set of criteria or data that we specify. In the case of reinforcement, this would be name, size, material, shape, and then bends. All we need to do is choose the report from the list in the Reports dialog and specify how much of the model we're reporting, either the entire model or just certain portions of it. Reports are an excellent way to quickly generate required data for either a portion or an entire scope of our project. Now, in addition to reports, we also have a function called the organizer. The organizer allows the ability to dynamically interact with our model object data. The organizer is kind of like a living spreadsheet that syncs with our model and then breaks the objects down into categories. These categories can be viewed independently or together, and the objects and associated object data contained within are provided in the object browser pane. The organizer allows users to filter to a specific set of objects in the model very, very quickly. What is currently displayed in the organizer can quickly be published to Microsoft Excel with 2 clicks of a button. The organizer allows for a large amount of functionality and customization in the way we view and report on the rebar and other objects within our model, and doesn't require the use of a template editor to customize. Now, regardless of the output method, getting quantities out of our model or specific portions of it is easy and fast. The data is already there, and this information can quickly be produced on demand or even updated after revisions are made to the model and then shared with project stakeholders. So it's very easy to understand and determine that efficiency and accuracy in detailing with instant quantification is our first major benefit to taking the time to modeling reinforcement inside of Tekla Structures. Now, although this has been a very high-level overview of our workflow's first pillar, it is enough to allow us to explore more deeply some of the other main benefits to modeling rebar in Tekla Structures. This brings us to our second pillar, Detail and Deliver. We'll look at constructability review, as well as numbering of reinforcement. In addition to that, we'll also dive into drawing creation and then rebar exportation for fabrication. Now, once we've reached the point where we can start producing initial reports on our project, it's time to start thinking about our deliverables. But before we get to creating our drawings and other output, there are a couple of things we need to or should consider doing. The first of those things is to number our reinforcement. Now, numbering can be done at any stage of the game, but it's usually at this point where users are probably going to consider performing initial numbering. Numbering in Tekla is defined as assigning position numbers, or marks, to parts, cast units, assemblies, or in our case, reinforcement. Numbering in Tekla is very fast and straightforward. We have highly effective numbering tools found right in the Drawings and Reports ribbon. All users need to do is load the appropriate setting, such as initial numbering, before creating drawings or after creating drawings. Each of these settings compares rebar in a different way and then applies marks to them. Initial numbering is going to renumber every bar every time, so it's great for getting marks on the bars while you're still proceeding to vet your model. The other settings will compare the bars that have been changed since they were first numbered, keeping the bar marks on the unchanged bars and giving new marks to new or edited bars. Simply load and apply the setting, select the bar that you wish to number, and then perform numbering. You can review the numbering results and then save them, and you are good to go. Numbering is always needed when detailing for fabrication, but it does also help in circumstances such as constructability review. To that point, we can illustrate a simple use case of constructability review now that we've numbered our rebar. Returning to our organizer, which again is great for reporting, but also very useful in QA and QC related tasks, we can resync with the model and now that we've numbered, which is technically a change to each bar's data. The marks in the organizer are updated and unique, and we can see the quantities for each mark. Here, we can review and filter out our bending schedule and see if there are any adjustments that need to be made. For example, bars that are very close in dimension to one another. As we can see, it's easy to identify that we have some number 17 bars that are within 1/2 inch of each other on the outside leg. This may be necessary, but also may not. We can select the bar right from the organizer and zoom to it in the model to get a better look. Since these bars are both corner bars, we can adjust them so they are uniformed in size. Then we can load up our numbering settings, select these bars specifically, and renumber them, condensing the bar marks in our model. Although a simple one, this is just one example of the power of BIM and the ability to produce and refine a vetted product even before creating drawings. The other end of constructability review would fall in a more traditional clash detection. This allows users to identify potential issues based on clearances provided in the model's options. Users can select the model and perform the clash detection and then review the results. You need to choose to either ignore, group, or resolve issues presented in the report. Reports can be saved so they can be worked and reviewed over time. Now, as stated, the software finds potential clashes on its own based on our tolerance criteria, and this is going to save detailers and users hours of manually checking the bar in the model or in drawings they already created. Ultimately, it is a reporting tool, and the user does need to still vet the results themselves for the clash detection, but it greatly expedites that process, allowing us to provide a more solid and competent product to our customers. Between the organizer and reports, as well as clash detection functions, users are able to produce a far more competent design efficiently and accurately from the start. That is the next major benefit to modeling rebar in a BIM platform, and the tools inside of Tekla structures keeps that process simple, accurate, and reliable. Now, we've seen so far that BIM can really expedite some of the tedious processes when it comes to rebar detailing. Numbering, constructability review, adding the reinforcement. Where we can really continue that trend is in drawing creation. Now, drawings are our bread and butter, and the ability to create accurate, fast, and efficient drawings is key to any detailing that we do. And so let's take a look at how we'll do that. Now, I have a model here up on screen. It's very partial. We have a 4-foot base mat here, and it's reinforced with number 9. Stock length is 40 feet. Got top and bottom reinforcement. We're doing splices, no mechanical connections. We have edge bar with staggered splicing as well over here on the edge. And then we have one portion of a wall that's detailed fully and attached to some other concrete. We can see here we have splice dials coming up from the base mat, and we'll have some additional reinforcement and some openings and blockouts. So, I was thinking maybe we could go ahead and do a drawing of the base mat, but that's a bit boring. So let's give ourselves something a little more interesting and talk about how do we create a drawing for our wall. Well, if I snap to my plane, I'm looking at it in plan view, which is great, but I may not want that right away. So what we do when we create drawings in Tekla, drawing views are a view of our model. So there's no drafting to be done, which is already a time saver, right? It is just a wireframe representation of our model. Now, we have the ability to open up different views of our model and different planes. So we can do elevation views, and you can create views based off of your grid. So if I open up the view on elevation of grid C, we're going to go ahead and see we have a nice flush vertical face to us. Now I'm showing a lot here. That's a bit more than I want to show in my drawing, and we really do need to look at this at least temporarily about what is going to be shown in my main drawing view. I really want to just focus in on this wall panel here. So if I go to the view ribbon, I can set my work area or the extents of my view by using 2 points, and I'm just going to do that. And I'm going to kind of click a crossing window just to kind of go ahead and dial things in. Notice a few things kind of got out of our way. The base mat reinforcement isn't so prevalent. This will be a good enough starting point. Now, to create general arrangement drawings, we have some commands so that we can load up the properties and create them from the ribbons here, but we can also access that by just right-clicking in the empty space of our view and hitting Create General Arrangement Drawing. It gives us a list of our views, and you'll notice our current view is highlighted. That's because we're using this view to create the initial drawing view. Now we can select more than one by hitting Control, and we can tell the dialog what to do with multiple views, such as put all of them on all views on one drawing, or one drawing per view, or create an empty drawing. We'll keep it simple. One drawing, one view. I can also load up the properties of my drawing, and so I have different settings available to me, and we have one that's for rebar, and this will allow us to populate some of these particulars for us in creating the drawings. Basically placeholders for the title block, as well as the way we're representing and calling out items, what scale our view is coming in, and a couple other particulars, as well as how our objects look and what format we're calling them out with. I'm going to use a derivative of this where I'm going to put no marks on the drawing. Now Tekla can put your callouts on there for you automatically, and all you have to do is nudge them around and clean them up. But that's pretty easy to demonstrate. What I'd like to demonstrate is also adding marks if you need to add something. So I'm going to do no marks first. I'll apply my settings, hit OK, click the Open Drawings checkbox so it opens the drawing I'm about to create, and then hit the Create button. Now again, remember, if you had multiple views like this of different wall segments, you could create all of your initial drawings at once and then move through them methodically and do some of the things that we're about to step through. So here I have an elevation on grid C. This is my near face, and I could probably double click on my view and update that view title to reflect that, and all I have to do is come to the label here, and I can see where that the field associates there, and we could change perhaps elevation on grid C to be wall 1 near face, and so on, and we could do that for the other side. I'm also showing my additional reinforcement, and I kind of want to get things out of the way a little bit, so we can use the power of filters to turn things on and off in our views. Now you can do this before you create your drawing, or you can do it afterwards. The choice is yours. Sometimes users find it's a little easier to do in the drawing in and of itself, but we can always select our filters and decide what not to show. So if I add a row, oh, we already have one there. I'll delete that one. If we go ahead and change the category, if the objects, let's go ahead and say if the reinforcement, we can choose a type, right? Reinforcing bar. If it's name, because I named these these diagonal bars with add bar. If it's name does not contain ADDL, then we'll go ahead and show everything else, right? Don't show this stuff is what it's saying. If I go ahead and select my view and then apply this modification to the settings, it's going to turn off some of that add bar. So conversely, what we could do is create another view just like this and turn it on and off. Creating additional views inside of a model is pretty straightforward and easy, and we can do it from the Views tab. We can create section and details, we'll touch on that in a second, or we can create views from either an entire model view that we have existing or an area in the model. So if we click that button, go and tab over to this, we can select this view we've used once already, and then go back to our drawing. And we're going to have another view down here at the bottom, which is really nice. It's nice and identical, which we're going to want to change. One thing I'll do is I'll adjust that scale to be at 36 inches using the contextual toolbar. There we are. There we are. And we could change the depth up and down to show the far face of the reinforcement. Or for our example, I think it would be more dramatic to show just our additional reinforcement, just by filtering. And then we can proceed to go ahead and add dimensions and marks. So if I wanted to, I could come up and use some of the dimensions and provide overall dimensions of the wall. So we can just kind of zoom out and provide that string right there. And then we could proceed to do it horizontally as well. which is all well and good, and we can also use dimensions to kind of annotate some of our reinforcement if we have a lot like we do here. Say snap to those portions of the bar and provide a dimension string. If I double click on that, I could quickly load up some settings that allows me to call that out. I'm going to load this and apply to add a mark to that dimension string. And you can see it'll give me information, the number of bar, the size, as well as the mark and spacing. If I don't want the dimensions visible, I can also hide that. And then I can save this as rebar. Save as. Now it's available in my drop-down, and I can apply that setting at any time and then continue to go ahead and annotate, such as we do here. And although this is calling out the splice bar, it illustrates how we can quickly and cleanly go ahead and annotate some of that reinforcement. Now the other way we can annotate is by selecting bars and adding a mark. You can see here it's provided me with a string. I'll move this over here. We can actually nudge this up, but it's providing some of the same information we saw in our in our dimension string, the number of bar, the size, its mark, its spacing, and a plus or minus there. And that corresponds to our pen schedule, which is showing anything that's being shown in any of these views. Same thing here for our additional reinforcement. So we can create add bar plans and views very quickly. But like we said before, we can have the drawing do the heavy lifting for us. So as an example, we'll go ahead and just quickly get rid of that annotation. We can change the view properties to no marks, to having all bar with marks, and hit apply and modify. And it's going to go ahead and give us that reinforcement. And we can then quickly clean this up and go ahead and print. Now, once you've gone ahead and taken a few minutes to just update and clean up your annotation, you can go ahead and still continue to modify the drawings however you need. One thing that we haven't touched on quite yet is making like section or even detail views. Section cuts are pretty easy. You just choose the tool and then choose where to go ahead and provide a cutting line. And we'll just snap perpendicularly. Then we're going to pick our direction we're looking and how far down, estimation wise, using the graphic there. And then we can choose to show a bit more above us or just stay even with the line, and we'll just pick that and create that bounding box for our view. We can adjust this further to get precise as we need, but then we're just going to pick a spot where that's going to go. Kind of a little tiny here. We can go ahead and update those things. Now it's using some saved drawing settings. If I expand the view extents, you can see now it's kind of grabbing some of that bar. It is only showing the additional bar, if you notice, which is not what we want to do here. So quick and easy to adjust, double clicking on the view settings. And again, this is going to use the last applied view settings. Now you can always use any of your own view details here. Simply, I'm going to turn off that filter so we see the bulk of our reinforcement. You can delete that row and hit select the view and hit modify. And well, we've got a bit more reinforcement here, or a couple more tags we can go ahead and get rid of. I don't necessarily want redundant callouts per se, so I'd rather start with the blank slate and only annotate what is most important. The only thing I'd probably do is just adjust that scale so that it's a bit more in line with the other. But once we're all done, the only thing left to do is to create a print of this. We can go to the File menu, hit the Print Drawings option. It brings up a dialog box. We can choose from a couple different properties, setting our line weights and colors. We can print to a PDF, a plot file, or a printer. We can open the file or its folder when we complete, add a prefix or suffix to the file name, and as well as choose whether we're printing in color, black and white, or grayscale. Generate our preview there so we can switch between that depending on what we want, and go ahead and then hit print. That's going to go ahead and open that up for us. Batch printing can be accomplished through the document manager. So when you create different drawings, they're all going to be listed over here in the document manager. You can filter to just your general arrangement drawings, and you can select multiples and then right click and go to print. Now, there's one final point I'd like to make when it comes to creating our drawings for rebar detailing. And that is that typically speaking, you or other detailers are going to have your drawing settings established, right? It doesn't take too much to get them going, changing out your title block, making sure that your dimension styles and part marks are in the format that you want. And as you saw when I changed the drawing settings from having no marks to having all marks, all that work was done for me. All I had to do was kind of adjust those marks to make sure they look clean and align them. And there's tools in the annotations ribbon to help assist with that. The key here is to highlight the reduced amount of work when it goes into creating drawings, and that with Tekla structures, production of drawings is reduced to simply annotation and layout, and this is accomplished in a fraction of the time required, usually using traditional drafting. Furthermore, we can also see the benefit that there's a reduction of errors between views and their corresponding bending tables. So there's a lot of time to be saved when creating the drawings, as well as the appropriate bend tables. So for those of us who are sitting there and thinking, well, this is great, but I feel like modeling is going to take me a little bit longer than my traditional process, maybe in the beginning that might be correct, but you're still going to make up a lot of time when it comes to producing your deliverables. And as you become proficient in that modeling, in those modeling tasks, you actually are going to have an overall time savings in your process. Now, we also have the ability to add more to that and make our life and the fabricator's life easier. And we can export our rebar based off of the model geometry directly to bending machine formats in either ASA or Soule format. Let's go ahead and take a quick look on how we could accomplish that. Now in the applications and components, we have a couple of tools that allows us to do that. The Rebar export tool, if we double click on that, is going to bring up a pretty unassuming dialog box, but this allows us to populate the headers and things like that and export to the appropriate file type for the bending machine that we are concerned for producing. So first we'll want to, on the output options, choose a path. Now I have populated one over here as a test, so let's go ahead and do this as test 2, and this is going to currently save us as an ASA or a ASA-DOS or .tek file. We can go ahead and ask to create an Ifc file if we want to, as we're going ahead, and if we want to select anything using a specific filter. We'll do this a little bit more manually for our demonstration. And then we can go ahead and proceed to populate the header that is required for the file type for the bending machine. The release name, job name, number, grade, format code, and so on. And you can see here I've gone ahead and populated something related to our example. The idea here is to select a portion of our model, typically what corresponds with some of our drawings, and export that file so that it accompanies the drawings as part of our deliverables. To do so, we'll use this wall as an example. We want to export the reinforcement in this wall, not the base mat. So what I'll do is I'll select the assembly types and select that wall, right click, and then just hit show only selected, which will get things out of my way pretty easily. Now I still have some reinforcement here, the developed bars down below that I don't necessarily want to select. So I'm using a selection filter to only select rebar, so I'm not grabbing that concrete. And then I'm just going to deselect these bars here, as I don't want them to travel, and they will be contained within another file for the base mat in and of itself, and I don't want to duplicate information. So here we are. Very simple. Now, if I had a filter to isolate just this wall's reinforcement, those would already be gone and be doing some of the heavy lifting for me. But for here, I think this will easily show you how to adjust on the fly. Once we've selected our reinforcement, we can simply select the Export Selected button, and then the tool is going to go ahead and then create that file for us. It'll save it into our model folder, as Tekla Structures models are not a single file, but a folder directory, under the appropriate Rebar Export subfolder. Once this is done, the dialog box will then pop back up onto our screen, and we can open up our model folder, going to the file menu over here on the top left, open model folder, and bring that up, and then choose Rebar Export. And then here's our file, test2. Now you can preview the information inside by opening up this file in any text editor, so you can see the header information and the size, the grade, and the format that we've provided for the bending. But this can be sent along accompanied with the appropriate drawing, so the name would probably mirror the drawing name. And then you've provided a complete deliverable very quickly. And that leads us to our fifth benefit of modeling reinforcement inside of BIM, and that is direct exportation of a BIM model's reinforcement to fabrication machines provides for efficiency and reduction in waste. All right, so that's going to bring us to our third and final pillar, collaborate. Now, collaborate can mean a lot of different things depending on who you are and what part of the process you belong to. Collaboration in a detailing sense could be the collaboration between a reviewer, a detailer, and an approver. But collaboration could also mean interacting with other stakeholders on a project, whether it's other commodities such as MEP, or it's dealing with the general contractor and his collaboration with all those moving parts that he has on site using your detailed rebar. Regardless of where you fit in the overall design to construction workflow, Tekla Structures has the ability to collaborate with others both inside the actual software and outside of it. And we do this through something called Trimble Connect. So for those who don't know, Trimble Connect is a cloud-based platform that allows users and detailers to share and connect their models with those who matter at any given stage of a project. Features of Trimble Connect include model viewing and sharing of object states, basically the way the objects look in your model. It also provides document storage, and you can link those documents directly to objects in the model associated with them. We can report on model object data, so we can look at the parameters of our bar, look at the weight, know the size, know the material. We can review this information. It also has built-in communication tools with to-dos. To-dos are a way for us to select objects, annotate and provide comments, and then assign it to a person so that they receive it via email, as well as in Trimble Connect, and they can act upon it. We can status share inside the Trimble Connect viewer. Trimble Connect accepts many file types with 3D formats such as Ifc, .Tekla, 3D CAD, and even 2D CAD files, PDFs, and so on. The cool thing, though, is that Trimble Connect is available on the web through your browser, as a desktop application, and on your mobile devices such as tablets and phones through an app. So let's go ahead and take a look and see what it's like to get your rebar model into Trimble Connect so that you can start collaborating. For rebar detailers, Ifc is probably the best format to send our models to Trimble Connect, and we can go to the File menu in Tekla, then Export, and select IFC4. And the reason IFC4 is so that we can go ahead and ensure that we're organizing our concrete and rebar using porous technology, as you can see here. All we need to do is ensure that we're either selecting a portion or the entire model, and then click Export. There are a couple of other parameters you can see in the dialog here, such as a file name, as well as what type of objects, and if they're color representation, and any additional property sets or information we may want to include. Once we click the Export button, it just takes Tekla Structures a couple of minutes to go ahead and produce that IFC file. In this particular example, we're using ifc.zip to keep the file size to a minimum. And once this does, we can find it in our model folder and then upload it directly to Trimble Connect. To get to Trimble Connect, all we need to do is go to the top menu in Tekla Structures and hit Trimble Connect to the ribbon, and then click the For Browser button to open it up. This is going to bring us to a project that is associated with our model, and if we don't have one associated, it's going to prompt us to do so before opening Trimble Connect. From here, we can go ahead and upload our model and then go ahead and access it. Once we find the model, the IFC zip that we have here, we can select it and simply click View. At this stage, it's going to open up a model viewer right in the web browser for us. And we're going to be able to see our model just as it was inside of Tekla Structures. So really, as you can see, getting your model into Trimble Connect for collaboration is simple and straightforward. But then the question stems, well, great, but what am I going to do with it? Well, we can kind of break this down in a couple of different categories. And I think the first one is probably we could review our model and also report upon it. So one thing that we can do once we have our model in there is break it down into different views. Now, views in Trimble Connect kind of act like save states, and we can turn different objects on and off. Now, in this video that we're showing here on screen, this is actually the same model we just uploaded, but only one portion of it. In fact, this is a specific pour within that entire project, and the rebar associated with it. Concrete's been turned off so that we can see the reinforcement in and of itself, and we're creating views here on screen and providing descriptions of them so that we can help others who join our project here for collaboration to navigate this. And you'll see in just a moment that once we have views established, we can actually click between them on the view pane on the left-hand side there and go back between those different save states of our model. It allows a lot of easy navigation and isolation of objects that are important, and we can create them in such a fashion that they represent either the design intent or the work to be executed out in the field. So let's go ahead and see how we can switch back and forth between views. We can reset our model and bring everything back, and then click on the view we just created here for that pour 2. And as we do, the model is going to go ahead, rotate to the appropriate position, and hide and enable the appropriate objects in the last way that we saved it. Now, aside from views and creating them and helping ourselves and others navigate through the model, we can actually look at the object specifically and then pull information based off of the model. This opens up a lot of doors for either review phases during the detailing process, which eliminates basically the need to create drawings for review, or for collaboration of an understanding of the design in certain areas such as work execution and pre-job briefs. And if you recall all the way back to the beginning of our presentation when we were talking about the first pillar and reporting, the organizer was a key part of that. And the organizer actually makes a return here in Trimble Connect. We have the ability to go ahead and view object properties using the organizer right here in Trimble Connect. However, it doesn't require us to sync like it does in Tactless structures. We can simply select what's on screen and show some basic information on the bar. We can sort by any of the different categories or header types and then expand those groups and look at the information, or in our case, bar in between. This is really useful for those who are trying to get a general understanding of the design configuration and the way the bar is detailed, or even for crews out in the field looking to see what bar goes where. So if we've numbered and then exported to Trimble Connect, that information can be reported here, and they can double check against the 2D documentation you've created later in the process and execute the work with confidence. In addition to reporting, the organizer can also help us navigate around our model as well, in conjunction with the views we've already created. Now, we saw how we isolated some of our pores and reinforcement contained there within, and then views its properties in the object browser down at the bottom portion of the screen. But with the organizer categories on the left-hand side, we can actually go ahead and make selection of objects that much easier. To do so, we'll go back to our property browser and then start selecting our entire reinforcement again. From here, we can also color code our reinforcement to help it based off of the grouping that we have here by name. It's really easy to do so. Once we have the filter in place, we can just quickly click the colorize button at the top, and it's going to provide a color associated with a representation in the model view. And we can save this to the organizer, and what this allows us to do is select objects and view them directly by that classification, or say by name. We can even rename this as Rebar Pour 2, and as you can see here, we're able to go ahead and isolate those different portions of our reinforcement for inspection, discussion, review, and so on. Using the organizer, it just allows us an easy way to select, navigate, and isolate objects of interest for us. So if we take a moment just to digest what we've seen, being able to create views and view the properties of objects through the organizer inside of Tekla structures allows us not only to collect information directly from the model, but also isolate objects and move through it and review. So the question is how does this help us? And it's actually quite helpful in a couple of different areas. If we want to keep it basic, we can look at the design and detailing phases versus the construction phases. Both phases, the models can be shared at any stage and at any level of design. So as you're working, you can continually export and share with those involved in the project at that stage. This gives them transparency in the model that you're creating and helps provide input or valuable direction as you're going before you ever need to create documentation such as drawings. The views that we created allows users to isolate portions of the model and easily communicate areas of interest. And they act like save states, and that's universal. And lastly, as it's been stated, this is a platform for review and comment. So within the design detailing phases, this acts as a portion of quality control. But during the construction phase, we can look at it from a standpoint of reviewing job scope and work execution plans, and even using the model to discuss the specific work executed in pre-job briefs. That kind of leads us to our next benefit, that collaboration using a BIM model through Trimble Connect allows complete coordination within a team or between stakeholders on a project without the need to create drawings first. You can get that valuable input and that direction that may be needed to get the job done right without going through several revisions of drawings first. So to round out this discussion on using a BIM model to collaborate throughout the process, we cannot forget to mention status sharing. We status every step of the process, whether it's from the initial concept, design phase, to pre-construction, and to construction. And Rebar is involved in a good portion of that. So we can status our bar in several different ways. Now there's a status sharing tool that's available within Trimble Connect that can actually talk directly back to Tekla structures, or it can be communicated between Trimble Connect users on different platforms such as desktop or web versus mobile. So the ability to select objects and then assign a status to them associated with a date is quite valuable. We can create different status sets for different tasks. Internal review of the detailed bar before fabrication. Fabrication process in-house. Has this bar been fabricated? Is it in progress? Is it not? These sort of things are very valuable to track and then can be communicated back to the Tekla model proper and even documented in UDAs on dates and times. Status sharing can also be accomplished from the field via your mobile device. As the bar is being installed and the embed's put in and the formwork goes up and then the concrete comes in, you can status all those different stages throughout. So by detailing our bar in a BIM platform such as Tactless structures, we can provide value to our customers who have to actually execute that work. The concept of status sharing is pretty straightforward. But with that said, it's probably not a bad idea for me to give you just a highlight of how it might work through Trimble Connect in and of itself. So let's pull up Trimble Connect through the web, and we can go to our information pane on the left-hand side and bring up the status sharing. Now we can see that all the concrete goes gray, and we can choose between different status sets. Right now, we're looking at a design status, but we can also choose from rebar installation or rebar shipment, and we can see that the colors correspond with different statuses. Green being completed, yellow in progress, red paused, and so on. Now let's bring up our mobile device, and as we can see on our mobile device, either at the shop or in the field, we can also status objects, and we can go ahead and select our concrete objects on the actual tablet or mobile phone and then change the status based off of the predetermined status groups that we have in Trimble Connect. And if we give that a few moments, we'll be able to see the status update here, right there, in Trimble Connect on the web within 30 seconds. Now, another thing about sharing is we're able to associate the documents we create, either reports or drawings or so on, with actual objects in the model or Trimble Connect directly by clicking on those objects and then viewing that documentation. Now, we can do this manually by uploading a document to Trimble Connect, finding an object, right-clicking, and then associating. But we also have an extension within Tekla structures that's going to help expedite that process for us. So after the review process has gone through inside of the rebar detailing phase and we do create our fabrication drawings, we can then go ahead and perform the task of associating them with our objects in our Trimble Connect project. So let's briefly take a look on how that happens. So here we are back in Tekla structures with our original model that we've been viewing also in Trimble Connect, and we've been focusing on this pour down at the bottom left in the foundations, pour number 4. Drawing. We're going to link some associated drawings to that pour for us. Now, let's open up Trimble Connect really briefly and remind ourselves what we have going on. We're in the models folder, we're looking under the concrete subfolder, and we're turning on 270B main pours .ifc zip. So now that we have a basis of what Trimble Connect looks like currently, we'll be able to see the differences once we upload the documents. Now, speaking of the documents, we should probably take a look at the document we're going to upload. So first, I'll just isolate this pour, so in case we need to refer to it, everything else is out of our way. So I'll show only selected and kind of zoom in and make that concrete transparent as possible so we can see the bar. But then from here, we'll go up to the Drawings and Reports ribbon and then choose our Document Manager. Now, we have a couple of drawings already in here, but the one we're focusing on is that down at the bottom there with R4.2 for pour 4. So let's open that up. It's a pretty straightforward drawing for the foundation. We've got a couple of plan views, top and bottom reinforcement, each on the two faces of that, or the two sides of that pour. And then we also have a detail and a section cut associated with that reinforcement. So we'll keep our document manager open, then we're going to come to our applications and components in the right-hand pane, and we're going to search for the word linking. Now, this application, linking documents to Trimble Connect, can be downloaded from our Tekla Structures warehouse. And when you open it for the first time, it is going to prompt you to log in with your Trimble ID and password. So make sure you have that handy. But once you do, the dialog box will open. And you can see here that it's pretty unassuming. We got a couple of drop downs at the top. Basically, we can make some save settings and ensure we're selecting the correct project we're associated with, and then that file directory. Now below, we could select our IFCs, but for us, it's blank. But if we hit this ellipsis button to the right-hand side, we can go ahead and navigate our file structure right from Trimble Connect and select the correct IFC that we want to associate these documents with. Now, we don't need assembly or single part drawings. We're using only general arrangement or GA drawings. So what we do is we select that drawing in the document manager here on the left-hand side, and then we'll go ahead and adjust our options in the model. We could go for selecting only selected, whether that's documents and or objects in the model. And we also have the option for the tool to create the drawing print for us, a PDF essentially, or a DWG or DXF. But I have already done that, and so what we'll do is we'll change the dialog to use the existing PDF that I have. This is because I want it in color as opposed to monochrome, and I've printed it to color. So once we check that option there, we can go to the bottom left and begin the upload process. Now, once you click this button, your mileage is going to vary depending on how many documents you're uploading at one time. So it's probably best practice to move forward in doing this in batches if you have a lot of drawings you want to associate with your Trimble Connect project. We're just doing one to keep things tight and fast for our presentation here today. But you'll see the status bar. Go ahead and count up on the uploading process down at the bottom left-hand corner. And then once we're done, we can go ahead, back up to our Trimble Connect ribbon and reopen Trimble Connect for web. If you already have it open, you just need to refresh the page. But now in the models side pane, we can see we have a subfolder and our PDF for the linking documents. We're not seeing anything, so let's go ahead and turn on that IFC that we have. And once we do, and it loads up, we are going to see our familiar to-do icon here on the left, but now we have a new document icon on the right-hand side. We can click on that document icon. This is going to open this up in Trimble Connect in the web. If you're on a mobile device and perform this task, it's going to open up the PDF in the default document viewer you have on your device. So it will take you out of the application. Keep that in mind. So the benefit here is that we can quickly and very efficiently associate our drawings and documents with the appropriate objects in Trimble Connect, so that those invested in our project can view the model, understand it completely in 3 dimensions, and then also find the traditional documentation they're used to without having to search around. All right. So that was probably a good amount of information to consume in a single hour. So let's just recap to wrap things up. There's a lot of advantages to adopting BIM and detailing your rebar in Tekla structures, and we were able to highlight the first immediate 7 today. The first of which is efficiency and accuracy in detailing with instant quantification. As soon as we model our objects and reinforcement, Tekla knows the physical properties of those objects. No calculations, no spreadsheets, but instant quantification. Immediately, we understand the rebar's spatial relationship to itself and other objects in the model. This provides an increased efficiency in finding and correcting design flaws and oversights. Now, by creating a constructible model with our reinforcement, we can immediately see these issues pop up as we're modeling. The majority are caught visually, and then we can use clash detection to ensure nothing has been missed. Production of drawings is reduced to annotation and layout. It's accomplished in a fraction of the time that's required for 2D traditional drafting. Reduction of errors between views and corresponding data, such as bending tables. Views are representations of the model, and changes happen in both places simultaneously. Not to mention, our bend tables are populated automatically using filters and based what is shown on the drawing views themselves. Exportation of BIM model reinforcement to fabrication machines provides efficiency and a reduction in waste. Direct file creation for machine input using the model geometry ensures consistency between the export file, the model, and your drawings. Using Trimble Connect, we saw how complete coordination within a team or between stakeholders on a project happens without the need to create drawings first. Collaborating and sharing the model can happen early and does not require the use of drawings to convey the design intent. This allows teams to vet the design much sooner and with less effort. It also allows project management and contractors to effectively illustrate the job requirements in the field to the crews directly. The last main benefit we covered was the ability to provide a digital twin of the rebar design as a deliverable without any additional effort. Now, digital twin is a bit of a buzzword, but there is value in building your project before you build it. The reduction in errors and competency in design allows for a more confident and complete product to offer to your clients, as well as provides assurance in the ability to reduce rework at the construction phase. Now, lastly, and since I like symmetry in my presentations, I'll offer up one last benefit. Number 8. Effective communication of the design that reduces the likelihood of human error occurring as opposed to interpretation in 2D deliverables. We're human, and we're prone to making mistakes. It's inevitable. Modeling your projects in Tekla structures is a tool against human error, allowing for a complete visual representation that we can scrub and correct before ever experiencing the impacts of mistakes in the design or construction phases. I hope today's webinar has provided you with some perspective on why you would want to detail your rebar in BIM using Tekla structures. If BIM is new to you, I would like to point out that we provide many resources to help you get up and running, from the software's instructor feature on the right-hand pane or our online and searchable user manual we call Tekla User Assistance. The TUA contains not only articles and documentation, but also video tutorials on how to model your first pieces of concrete and rebar. I would also be remiss if I didn't mention the virtual classroom training we offer for those who want it. And with that, folks, I think we can come to a close. As a final note, we've put together a collection of additional video content related to today's webinar, and I'd like to encourage you to check it out. You can find it by typing the web address you see on screen, which is www.tekla.com/us/resources/constructible rebar detailing, dashes between the words. Or you can use your mobile device's camera and scan the QR code displayed. Once again, thank each and every one of you for joining me today, and have a great one.